Hey everybody, I hope you're having a great day. If you have any questions about square root functions, please make sure you reach out, join a Google Meet one of these days. Today we're going to talk about cube root functions and how to graph them. The difference between square root functions and cube root functions, one that you might notice right away from looking at this graph, is the domain now is not restricted. With square root functions, it was restricted. We couldn't have a negative inside of the radical sign. But with cube roots, well, we can have the cube root of a negative. So we'll see that the negative x values here are graphed because you can have the cube root of -1. Because if you multiply -1 by itself 3 times, you get -1. So that's why you're able to have negative values inside of the radicals. So the domain is no longer restricted. So the domain and range of all of these are going to be all real numbers. So we're just going to learn how to graph a few of them. So the first one we'll look at here, it says graph h of x equals the cube root of x minus 4 and compare the graph to the graph of f of x equals the cube root of x. So the first thing we're going to need to do is, well, since the domain's all real numbers, we're just going to make ourselves a table here. Just make the smaller x values. That'll fit. So let's look at our perfect cubes here. Well, we're going to want 0 in the middle right now because we have just x in there, so the cube root of 0 is going to be kind of that middle turning point. So we're going to put a 0 here. Perfect cube that's bigger is 1. -1 is a perfect cube. And then after that, the next perfect cube would be 8 and -8. Alright, so the cube root of 0 is 0. 0 minus 4 is -4. Cube root of 1 is 1. 1 minus 4 is -3. Cube root of 8 is 2. 2 minus 4 is -2. Cube root of -1 is -1. -1 minus 4 is -5. And the cube root of -8 is -2. -2 minus 4 is -6. Notice how our y values here are going up by 1. So we are going to graph this. So we start at 0, -4. 1, -3, and then 8, -2, and on the other side we have -1, -5, and -8, -6. Alright, and then we're just going to connect it with a nice smooth curve. See how I do here. I'm getting better. That's not too bad. Alright, there's our graph. So now we're going to compare it to the parent function, which is f of x equals the cube root of x. So if we notice from what we're dealing with here, we are subtracting 4 from the outside. So it's outside, so it's vertical. We're subtracting, so it's adding or subtracting is a translation. It's a vertical translation, down 4. So it's a vertical translation down 4 units. Alright. So the transformations are still the same. If you're multiplying inside, it's a horizontal stretch or shrink. If you're multiplying in the front, it's a vertical stretch or shrink. If you're adding or subtracting inside, it's a horizontal translation. Alright, so let's now take a look at these two. Pause your screen and try these two out. When you play, we will see the answers. Alright, so I'm going to go ahead and just paste this table here. I'm going to use these numbers because, again, it's just x inside of the cube root symbol. So these are my perfect squares that I want. So 0 would be 0, 1 would give me 4, 8 would give me 8, -1, cube root of -1 is -1, times 4 is -4, and -2 times 4 is -8. So now we'll go ahead and graph these. I have 0, 0, 1, 4, and 8, 8. And I have -1, -4, and -8, -8. So I'll go ahead and try to draw a nice smooth curve through these points. Alright, so that is our graph of g of x equals 4 times the cube root of x. So comparing the graph, it is a vertical stretch by a factor of 4. Okay, so number 1 is a vertical stretch by a factor of 4. For number 2 now, I'm not going to want to use these numbers because if I use 0, I'm going to have -5, and I don't want the cube root of -5. So if you think about it, if you want it to be 0 inside, right, we're going to want to make it this 5. So we'll make it 5 more. We'll make this 5 more, and then we'll get 1 on the inside. And if we made this 5 more, we would get 18 on the inside. Or 8 on the inside. So this, if we made it 5 more, we have 4. And this would be -3. Alright, so if I made 5, I'd have 0. 6 would give me the cube root of 1, which is 1. 13 would give me the cube root of 8, which is 2. 4 would give me -1. And -3 would give me -8, which is -2. So now we'll go ahead and graph these points. Got 5, 0. 6, 1. 4, -1. 13, 2, it's going to be over here, so just going to know that I'm not going past 2. And then -3, -2. Alright, so I'll just draw my nice smooth curve as best as possible. Alright, so that is my graph. The comparison, not a great graph, but my comparison, since I'm subtracting 4 on the inside, it was a horizontal translation 5 units right. So number 2, the comparison is a horizontal translation 5 units to the right. Alright, now the next thing we're going to do here is there's a couple things happening. We have a reflection. So it says graph g of x equals the negative cube root of x plus 2. So why don't you guys give this a try, see what you get out of it, and press pause. When you're ready, press play, and we'll do it together. So just break out my table again. I'm not going to want to use these again because I'm adding 2 on the inside. So if I kept it 0, I'd have the cube root of 2. Not that there's no cube root of 2, it's just it's an irrational number, and I don't really want to graph an irrational number. It's kind of tough. So instead, I am going to make it 2 less, so I'll make it -2. And I'll make this 2 less. I'll make it -1. This will become 6. This will be -3. And this will be -10. There we go. Alright, so if I plug in -2, I'm going to get 0, because the opposite of 0 is still 0. If I use -1, that would be 1. Cube root of 1 is 1, but I make it negative on the outside, so that would be -1. 6 would give me the cube root of 8, which is 2, and I make it -2. -3 would be -1, which then would become +1. And then this would be -8, which is cube root of -8 is -2. The opposite of -2 is +2. So now we'll go ahead and graph these. -2, 0. -1, -1. 6, -2. -3, 1, and -10, 2. I'm going to draw my nice smooth curve as best as possible here. And that is my graph. Now for my transformations from the parent function, it is a reflection and that'll be in the x-axis. And it is a horizontal translation, left 2 units. Alright, so that's just a couple things to go off of here. So at this point, if you could just do the big ideas problems that are assigned. If you have any questions, please reach out either on the Google Doc or come attend the open meet and discuss them there. Alright guys, good luck today.